Yeah. So we'll continue with the functions, and now I'm going to start with inverse functions, especially talking about inverse trigonometric functions. Inverse trigonometric functions. I think in the class today, we discussed a bit about it.
Yes, sir.
So today we'll have a full-fledged session on this inverse trigonometric functions. Now, inverse trigonometric functions are nothing but inverses of the 6 trigonometric functions that we know, that is sine, cos, tan, sec, cosec, and cot. Okay?
Okay.
But we had learned in the last class that if a function has to have an inverse, if f of x is invertible, then f of x has to be a bijection.
Right.
Then f of x must be a bijection. Must be a bijective function, or you can say a bijection. What is a bijection? A function which is one to one and onto both.
And on to you.
Right? Onto means range and codomain should be same, right?
Right.
Okay, so let us start with sine function. Let's say I want to inverse sine function. Okay. And let us say I define sine function from all real numbers to all real numbers. Okay, let's say this is how I have defined my sine function. So I have chosen my domain to be R. This is your domain. And I have chosen my codomain also to be R.
Okay.
Okay. Now you tell me, under this definition, is sin x function invertible?
No.
Absolutely correct. Sin x function will not be invertible because the graph of it will be like this. And remember, if it has to be a 1-1 function, it must not be cut by a horizontal line at more than 1 point.
More than 1 point.
Right. So in this case, it is cutting at so many points, correct? So under this definition, it is not invertible. So it is not invertible under this definition. So what I will do is, I will restrict my domain and of course my codomain.
Pi by 2 and pi by 2.
Right. So if you restrict it to, let's say, minus pi by 2 to pi by 2, then what are you doing? You are actually curtailing the graph of this function only to this interval. So it will be a graph like this. Okay. This value is minus pi by 2. This value is plus pi by 2. Normally, this branch is chosen to be the principal value branch.
Okay.
Okay. You could have taken other branches as well, like pi by 2 to 3 pi by 2, or 3 pi by 2 to 5 pi by 2, or 5 pi by 2 to 7 pi by 2. That would also work. But normally the consortium of mathematicians decided that we'll refer this branch as the principal value branch. So unless until stated, we'll deal with this domain of the function, and this, of course, codomain. In fact, this is the range of sin x graph, which is from minus 1 to minus 1. And under this interval only, we'll consider the function to be invertible. Okay?
Okay.
Now, how does the inverse function, or how is the definition of an inverse function look like for this? So if I already told you in the last class, so if this is the domain and this is the range of f of x, then the domain and range for its inverse will be just opposite.
Inverted. It is opposite. Yeah.
You just have to swap the position of the domain and the range. Okay. And of course, we write it like sine inverse of x. How would the graph look like? Yesterday,
exactly. It's inverted about the y-axis, I think.
No. Yesterday I told you the graph of f of x and its inverse are mirror images of each other.
Oh, right.
About
Mirror
y
images.
equal
So
to
it's inverted about the x-axis.
mirror image about y equal to x line, correct?
Oh, y equal to x.
Yes. So if I draw a y equal to x line over here like this, okay, the mirror image of this function about this line is what will be the graph of sine inverse of x. Okay, and the graph will actually appear like this. Okay, can you see the
Right.
graph?
Yes, sir.
Yeah. Now, what happens is when you are taking the mirror image of this function about y equal to x, whatever you are writing on the x-axis will now jump to the y-axis, and whatever you have written in the y-axis will now jump to the x-axis. So this value over here, 1, will actually be the value at this point. This will be your 1. Okay.
Okay.
This
Okay.
-1 will come over here. So this value will be -1. This pi by 2 will go on the y-axis. So this value here is pi by 2. Okay. And this minus pi by 2 will come on the negative y-axis like this.
Okay.
Is that fine?
Yes, sir.
Okay. So remember, when I'm talking about sine inverse function, I have to only cater to this domain and range intervals. For example, if I ask you what is sine inverse of minus of half, what will your answer be?
Sine inverse of minus pi by 6.
Minus pi
So
by 6.
minus pi by 6.
Right. Never say it is going to be 7 pi by 6 like this, because it doesn't
It's
fall in.
not between minus pi by 2 and pi by 2.
Absolutely. It is not in the range of the sine inverse x function. Okay. Now, a couple of things from the graph, you can note that the graph is symmetrical about origin. So what is the nature of this function? Is it an even function or odd function?
Odd function.
Exactly. So this will be an odd function. And odd functions are known to satisfy the property f of minus
F of
x
minus x is equal to minus fx.
minus f of x, right? So in light of this, I can say sine inverse of negative x is negative of sine inverse x. Is that fine?
Yes, sir.
Okay.
So none of the properties in a normal trigonometric function will apply to an inverse function, right?
Sorry, I didn't get you.
None of the properties
Huh?
will of a normal trigonometric function will apply to an inverse trigonometric function.
See, it would be wrong to say that none of the properties, they're different things. In essentially, trigonometry is the same. You're now dealing with the properties of the inverse. So sin x will continue to behave as sin x. Its inverse will continue to behave as its inverse. So the properties sets are different in the sense that they are both different things.
Okay.
Okay, they are inverses of one another.
Right.
Okay.
Yes, sir.
So now let us go to inverse of cos. So let's say cos function. Again, I am defining from R to R. Will it be invertible in this particular domain and codomain range?
No, sir.
No. So how should I curtail my domain and range for it to be invertible? You can take a clue from the graph of
0
cos
to
x
pi?
function.
Is it 0 to pi?
Correct. Basically, you have to curtail the domain in such a way that you don't allow the curve to take a turn back. Because the moment you allow it to take a turn back, it will be cut
in the
by
horizontal line. It will cut it at 2
absolutely
points.
It will be cut by a horizontal line at more than 2 points. So here in this case I will have to ensure that I don't allow that to happen. So I will take the interval 0 to pi, and of course I will make the codomain equal to the range. Okay, so under this definition your cos x function graph would actually appear to be just this part like this. Okay, from 0 to pi. Correct?
Yes, sir.
So if I have to define the inverse of the function, it would be defined from -1 to 1 till 0 to pi. Okay, and the expression that we use is cos inverse of x. Okay, what about the graph of it? For graph of it, we have to imagine the reflection of this graph about y equal to
y equal to x line.
Yes, so this is your y equal to x line. So how would the reflection be about this line? Can you try it on your notebook?
Yes, sir.
Now, it is very difficult to imagine the reflection of both the parts of this graph about y equal to x. Okay, but I'll tell you a shortcut for that. In fact,
Okay.
the final answer would look like this: the Hindi alphabet for. Okay, so this point will be pi. This point will be pi by 2, and of course this is 0. This will be 1. This will be minus 1. Actually, what happens is that this part will be reflected like this, correct?
Right.
And this part will be reflected like this. Are you getting
Oh.
this?
Yes, I
So
got that.
this yellow part, this part is the reflection of this, and this part is actually the reflection of this part.
Okay.
Okay.
Okay. Fine.
Another way to realize the same thing is, in case you're not able to imagine the reflection about y equal to x, what I normally tell students is that if you want to get the graph of inverse of any function, follow these two steps. Step number 1 is reflect the graph about x-axis or in x-axis. Okay.
Yeah.
And step number 2 is rotate the reflected graph of step 1 reflected graph of step 1 90 degrees anti-clockwise.
Okay.
So let's say I
Yeah.
want to invert the graph of this function. Okay, so first of all I would reflect it about the x-axis, which will look like this, correct?
And then rotate it.
And of course, yes, and then we rotate it 90 degrees anti-clockwise. So if you rotate it at 90 degrees anti-clockwise, you will see that this will actually become your x-axis, this will actually become your y-axis, correct? So it'll start looking like this.
Oh, okay.
Got the point?
Yeah.
Or you could also reflect it about y-axis and rotate 90 degree clockwise. So both of them would give you the same output.
All right.
Okay.
Yes, sir.
Now I would like to ask you one question. Tell me, what is the value of cos inverse of minus half?
Cos inverse of minus half. Pi by minus pi by 3.
Minus pi by 3. Now Shreya, see the fundamental mistake you have made. Your range is this. How can minus pi by 3 fall in this?
Oh. Oh, right.
Your answer should be an angle which is between 0 to pi, such that cos gives you minus half for that angle.
Okay, so it should be pi minus pi by 3.
Pi minus pi by 3. How much is that?
2 pi by 3.
Absolutely correct. Okay. So these are the things which people initially make mistakes on. Tell me, what is cos inverse negative root 3 by 2?
Pi minus 5 pi by 6.
5 pi by 6. Absolutely correct. Okay. Now one thing is worth notable, that cos inverse x graph is neither odd nor even. Okay.
Oh.
So
okay.
Unlike the previous observation that we had, sin x was odd function and so was sin inverse x, correct?
Right.
But in this case, even though cos x is an even function, cos inverse x is neither odd nor even, because for it to be even, it has to be symmetrical about y-axis, which it is not, isn't it?
Okay. Yes, sir.
And for it to be an odd function, it has to be symmetrical about origin, which is neither. Yeah, that is also not true.
Right.
Okay. Now let's talk about tan function. Again, let me first take this definition. First of all, tell me, is this the right domain of tan function? Can R be the domain of tan function?
No, sir. No.
No. So this is not the right domain. So what should be the right domain? Tell me. Is tan function always defined?
No, so it's not defined when in 90 degree.
Just 90 degree?
Multiples of 90 degree. Multiples of pi by 2.
Multiples of pi by 2. But tan 180 degree is defined. It is 0.
Pi by 2, then 3 pi by 2, and odd multiples of pi by 2.
Right. Now that is the right word to use. You have to have all real numbers except odd multiples of pi by 2. Note that I am writing it in curly brackets representing set of points where the angle becomes odd multiple of 90 degree. Okay. What about the range of tan function?
Range is 0 to
No, it's all real numbers.
all real.
Yeah, tan function graph is like this, na? Tan function graph is like this. It keeps on going from minus infinity to infinity, right?
Oh,
so
right.
This value is pi by 2. Again, it will come like this. So we'll cut it at pi. This will be 3 pi by 2. And keeps on going in a similar way. Okay? Like this. This is minus pi. This is going to be minus 3 pi by 2. And so on. Now, is this a 1-1 function? Definitely not. Because if I draw a horizontal line, it will cut the graph at so many points.
More than 1 point.
Yes. Okay. So if I want to make it a 1-1 function, how should I curtail my domain of the function? Can you suggest me an interval where I should restrict my domain for it to be 1-1?
0 to pi by 2.
But if you take 0 to pi by 2, you will not do just the range will not be all R, right? You want it
then
to
you
be
can take minus pi by 2 to pi by 2.
Right. Inclusive or exclusive?
So you're mentioning that means must be exclusive only.
Of course, it is not defined for minus pi by 2 and pi by 2.
It's not defined.
Yeah, so please make sure the brackets that you use should be the round brackets. Okay, so under this definition, you can actually define tan x to be a bijection. Okay.
Right.
Now, if I have to define its inverse, so of course we will have from R to minus pi by 2 to pi by 2
to pi.
Okay. Can you help me to sketch the graph of tan inverse x function?
Yes, sir.
Remember what I told you? If you have
yes,
problem imagining its reflection about y equal to x, first reflect it about the x-axis and then rotate the reflected graph 90 degrees anti-clockwise.
Yes, sir, I got it.
You got it? So you would realize your graph would be appearing like this.
Yes, sir.
Okay. So as you can see, its domain is all real numbers. That means it extends all the way from minus infinity to plus infinity. And its range will be from minus pi by 2 to pi by 2. So basically, you would realize that y equal to pi by 2 and y equal to negative pi by 2 are asymptotes to this graph.
Right.
Y is equal to pi by 2 and y is equal to minus pi by 2 are asymptotes. We'll talk about asymptotes also in some time. What are asymptotes? Asymptotes are lines located at
x-axis or y-axis.
Sorry?
They don't touch the axes.
Yes, asymptotes are basically lines which are at finite distance from the origin and appear to touch the curve at infinity. Okay. Now, a quick question. What is the value of tan inverse minus 1? Just to check your understanding of the function.
Minus pi by 4.
Minus pi by 4. Absolutely correct. Is this an odd function or even function?
Is it an... But it's symmetrical about the origin.
Absolutely.
So it's odd.
Odd function. Very good. Odd function. And odd function, we know that should satisfy the characteristic tan inverse negative x is negative of tan inverse x. Okay. Now, actually, I didn't tell you what happens in case of cos. Cos of negative x is actually pi minus cos inverse x. So please make a note of this.
So 1 second. Yeah, okay, change.
Sorry?
Yes, sir, change. Yes.
Okay. Now, couple of things that we need to note. In fact, we have to complete the other 3 inverse trigonometric functions as well. Cosec x function. Okay. Can you tell me the domain and range of cosec x function?
Sir, a range I know is from 1 to infinity union -1 comma minus infinity.
Okay, so minus infinity to -1 union 1 to infinity. That's absolutely correct. What about the domain?
All real values?
All real values. Now see, cosec x is 1 by sin x. So will you allow
Right.
sin x to become 0?
No, other than 0. All real values -0.
Okay, that means sin it can take pi.
Okay, so all 0 pi 2 pi.
So generalize
4.
it.
So it's all even multiples.
Even multiples of pi by 2, or you can say all multiples of pi.
Right. Okay.
Okay. So under this
Right.
definition, the graph of cosec x appears to be like this. So this is the graph of cosec x only. I think yesterday we had seen the graph also, right, for this?
Yes, sir.
Okay. So this value here is 1. This value here is -1. Okay. And at all multiples of pi, the function is going to be undefined. So if you want this, if you want this function to be invertible, can you suggest me? In fact, if you want this function to be 1, 1 and on 2, can you suggest me a domain and range?
Minus pi to pi.
Minus pi to pi. So minus pi to pi, it will take so many turns, right? So if I draw a horizontal line like this, it will not be a 1, 1 function, correct?
Okay, no, minus pi by 2 to pi by 2.
Absolutely correct. So you have to curtail it between minus pi by 2 to pi by 2. Okay. So this will be minus pi by 2 to pi by 2, excluding which point? 0.
Excluding 0.
0 cannot be included in your domain ever, because you have to exclude all multiples of pi. Yeah. Now, this will be untouched, -1 to minus infinity to -1 union 1 to infinity. Now, sometimes you would realize that this interval is also written as all real numbers minus of minus 1 to 1. Okay. Yeah. Now, if I have to define the inverse for cosec x function, what should be the domain and what should be the range? Quickly tell me.
Domain should be r minus -1 comma 1.
Okay. Or you can say
And-
minus infinity to -1 union 1 to infinity.
And range should be minus pi by 2 comma pi by 2 minus 0.
0. Okay. Now, if I have to draw the graph of this function, remember I'm only dealing with this part of the branch, this part of the graph, from here to here and from here to here.
So it will be half of that, right?
So this is pi by 2, this is minus pi by 2. Okay. I have to invert the graph of this. How will I do that? Please make the graph on your notebook. Any physics class happened for you so far, or chemistry class?
No, sir. It's starting tomorrow.
Starting tomorrow. Very good. Physics or chemistry?
Both.
Both. Okay.
I have chem in the morning and physics in the evening.
Wonderful. Okay.
Sir, this timing will remain constant irrespective of, because I have center on Saturday, especially because Saturday is from till 7:30, right?
Yeah. Saturday, see, mostly Saturday I'll keep it from 9 to, let's say, 8:30 to 10:30, like that.
In the morning, in the night.
No, morning is not possible because I'm going to NAFL school, right? So
Right. Okay.
yeah.
Okay. So one more thing on the group, 2 weeks ago, you sent a schedule about talking about the timings. What was that?
Yes, actually, what had happened, we had decided to keep the batch separate. Okay.
Oh, but now you're combining
But
it.
I have but now we have combined it with the batch which used to come in the center. Remember when we started with the bridge course? You were with some of the people, so that batch itself has is combined with your batch.
Oh, so there's no more school batch now.
Yes, because both the batches were very small, so we didn't want to do the same thing twice. And of course, competition has to be there with other people also. That's why we combined it.
Okay.
Yeah. So what you'll do here, you'll first take the reflection about x-axis and rotate it 90-degree anti-clockwise. How would the graph look like then?
You have two arrows in the first and the third quadrant.
Okay. Just check whether your answer is, or the graph that you have drawn is like this. Okay.
Yes, sir.
So note that this point is at 1 comma pi by 2. This point is at minus 1 comma minus pi by 2. Okay. Again,
Yes,
same question for you. Tell me cosec inverse of minus half.
Cosec inverse is 1 upon sine inverse pi by minus half.
Yeah.
So there's a half exists in cosec?
Absolutely correct. This is not defined because your x has to be in this interval, isn't it?
Right.
Minus half is the excluded part of it, actually. Okay.
Right.
So I just gave you, to test your understanding.
You want to trick me, sir?
Yeah. Tell me what is cos inverse of minus 2 then?
Cosec inverse of minus 2 is pi by 6. The
Pi by 6?
minus pi by 6.
Minus pi by 6. Absolutely correct. What is cosec inverse of 2 by root 3?
Pi by 3.
Pi by 3. Absolutely correct. Okay. Now again a quick word. Odd function or even function or neither?
It's symmetrical about the y-axis, so it should
y-axis.
be even.
If it was symmetrical about y-axis, then this branch reflection should be like this.
Oh, okay. So, oh no, that's an odd function. It's symmetric about the origin.
Absolutely, it's odd function. Yeah, odd function. And if it is an odd function, what should be the answer for cosec inverse of negative x? Minus cosec
inverse x.
Minus cosec inverse x. Absolutely correct. Okay. So now let us continue this exercise for sec as well. So for sec function, can you tell me what should be the domain and range?
So range is the same, right, as the cosec inverse?
Absolutely. Range is the same as cosec x, which is this. What about the domain of this function?
Domain. Isn't it all all even multiples of pi?
No, you want to exclude all odd multiples of pi by 2 because this is actually 1 by cos, right? So you don't want
Right.
this to become 0, correct? So you have to
Right.
exclude all odd multiples of 90 degree.
Okay.
Okay. And we know that the graph of secx will actually appear to be like this. So this is pi by 2, this is 3 pi by 2, and this is...
So the only difference between a cosec graph and a C graph is actually just shifted by pi by 2,
Exactly.
right?
That's why they are called complementary functions, because they are obtained by just replacing, just changing x with x minus pi by 2 or pi by 2 minus x. So they involve shifting of each other graph.
Okay.
Okay.
Yes, sir.
So this is the graph. Now, if I want this to be a bijection, how should I define my cosec function? Suggest me a branch where it is taking care of the entire range as well as not taking a turn back. That means it is not becoming an onto. It is not becoming a many one function.
So can you take minus pi comma minus pi by 2 union?
Just tell one.
0 comma pi by 2. So
okay, you want to say minus pi to 0 excluding minus pi by 2. Correct. Now that's perfectible. That is perfectly acceptable. But normally it is decided that the principal value branch would be from 0 to pi, this part to this part, excluding pi by 2.
Okay.
As I told you, there is a concept of principal value branch.
Right.
Which has been decided by the consortium of mathematicians to standardize the branch that we actually take.
Okay, sir.
So under this interval, your function is going to be a bijection. Okay. Now, if I want to define its inverse, it has to be from
minus infinity comma 1 union
minus
1 comma infinity 2 0 comma pi minus pi by 2.
Okay.
Right.
Defined as sec inverse of x. How would the graph look like? Can you draw the graph on your notebook? Remember, you are only inverting this part of the graph.
Yes, I finished.
Finished?
Yeah.
Great. So your answer would look like this. This is your 1, this is your minus 1, and this is your line, let's say pi by 2. So your answer would appear to be like this. This point is at pi. Okay?
Yes, sir.
Now again, quick question. Is it odd, even, or neither?
Neither.
Absolutely correct. Let me also ask you this question. What is sec inverse of minus 2?
Um, pi. So pi by 3. Minus pi by 3.
How can it be minus pi by 3? It is not in this permissible range.
Oh, pi. Pi minus pi by 3. 2 pi by 3.
2 pi by 3. Absolutely correct. What is sec inverse of minus 1?
C inverse minus pi. Pi by 2. Minus pi by 2. Oh. Sorry, minus 0. 0, 0, 0, 0.
0. But I can see here that sec inverse of 1 is minus 1 is pi.
So pi.
Yeah, this graph is drawn for some reason, right? You can refer to this graph as well.
Right, sir.
Okay.
Right.
What is sec inverse negative 2 by root 3?
Negative 5 pi by 6.
Absolutely correct. 5 pi by 6. Okay. So now we can discuss the graph of cot x function. Can you define the domain and range for this?
Range will be R.
Absolutely correct. Domain will be
All even multiples of pi by 2.
all even multiples of pi by 2 means it is defined like dots. Is that the case?
No. All odd multiples of pi.
All odd multiples of pi. Okay. See, Shreya, first of all, ask yourself. I have to just exclude those points which will make this function undefined. Correct?
So that is
So I don't
0.
want this fellow to become 0, correct?
Right.
So tell me, for what values of x does sine become 0?
0 pi, 2 pi.
Correct. So you don't want those values only, right?
Right.
So exclude those values from all real numbers. So I can say all multiples of pi has to be excluded.
Correct. And pi.
Yeah. Now, if you look at the graph of cot function, it will appear like this. Okay. Cutting at pi by 2 here. And this is asymptotic to pi. Okay. This is going to be 3 pi by 2. Again, asymptotic at 2 pi. And same trend will be continued on this side as well. So this will be minus of pi. This will be minus of pi by 2 and so on. So as you can see, at all multiples of pi, the graph is becoming undefined. Now such a graph, if you draw a horizontal line, will be cut at multiple points. So if you want it to be a bijection,
minus pi by 2 to pi by 2.
Okay, minus pi by 2 to pi by 2, normally we avoid, your answer is absolutely correct, but we avoid that interval because there is a discontinuity in between. Okay, so instead we take 0 to pi as our interval.
Oh, okay.
Are you getting this point? Now 0 to pi, the graph is not discontinuous anywhere. So you are absolutely correct. We could have taken minus pi by 2 to pi by 2, excluding one of the points. But since a discontinuity is appearing in between, it is preferred to take that interval where there is no discontinuity. Okay.
Okay.
Now there were discontinuities in sec and cosec, but that was unavoidable because we had to make it a 1 1 and onto function, right?
Correct.
But here there is another possibility of it to be 1 1 and onto. So why not go with that possibility where there is no discontinuity involved?
Correct. Okay.
So we take 0 to pi open interval.
Okay.
Okay. So under this circumstance, your graph will be just one single branch like this. Okay. From 0 to pi. Now, if I have to define the inverse of this function, I will define it from r to 0 to pi. And how would the graph look like? Can you draw the graph?
So I already drew it.
Oh, you have already drawn it. So the graph, check, it will look like this. Cutting here at pi by 2, and it will become asymptotic at pi. That's why 0 and pi are never included in your range.
Okay.
Quick word, is it even, odd, or neither?
Odd.
Odd. If it was odd, then this part
No,
would
no,
be
no, it's
like
not.
this.
It's neither. It's neither.
It's neither. Okay. What is the value of cot inverse minus 1?
Cot inverse minus pi by 4. No, that doesn't come in the
Yeah, you have to keep this range in your consideration.
3 pi by 4.
3 pi by 4. Absolutely correct. Okay. So let me tell you a property. Cot inverse of negative x is actually pi minus cot inverse x. So in this entire event, if you would recall, which were the odd functions that you came across?
Sine,
Right.
tan,
Right. And cosec inverse.
cosec. Right.
So sine inverse, tan inverse, and cosec inverse are the only odd functions among the inverse trigonometric functions.
Right.
Apart from this,
Why
there
are
is.
not even functions?
Sorry?
Like, is there an explanation for that?
No, there is no even function here. Yeah.
So why is there an explanation for that? No.
It is not necessary that every function has to be even or odd. There may be cases where there is neither.
Okay.
So few properties that we need to know about inverse trigonometric function, which will be asked in your AP exams. One is your cosec inverse x function is actually sine inverse of 1 by x. Okay.
Okay.
Same is true for sec inverse as well. Okay.
Okay.
Okay. And for cot, the rule is slightly different. It is tan inverse of 1 by x only when x is positive.
Okay.
Is that fine?
Yes, sir.
Next property that you need to know is complementary angle properties. That is, sine inverse of x plus cos inverse of x will always be pi by 2. Of course, x should be in the domain of the two functions, or the common domain of the two functions, which is minus 1 to 1. Similarly, sec inverse x plus cosec inverse x will always be pi by 2. Again, x has to be in the permissible domain of the two functions, which is minus infinity to minus 1, union 1 to infinity. And cot inverse of x plus tan inverse of x again is pi by 2. X
So
can
it's the
be
same
any
thing
real
as
number.
normal angles or normal
Yes,
trigonometry.
same thing as a normal trigonometric functions.
Yes, sir.
Okay.
Yeah.
Fine. So we'll take up some questions on this. Let's check some questions on this. First question is, Find tan of.
So how will you define cot inverse x in terms of cos inverse x and sin inverse x?
Okay, very good question. So let's do this question and then I'll come to answer your question.
Okay.
Now normally they can use arc sine, arc cos, arc tan in place of sine inverse, cos inverse, tan inverse, etc. So don't be confused. Arc sine means sine inverse x.
Okay. Oh, domain. Minus. So is the answer -1?
-1. Okay, so what is cos inverse of
-1 by √2.
-1 by √2? What is this answer?
-π/4.
Again, same mistake, Shreya. Cos inverse of anything can only lie between 0 to pi. So you cannot say -π/4 as your answer. That's why that range domain thing was given.
Yes, sir.
Okay.
It's confusing. I'll take a day to learn that. 3π/4.
Yeah, I
Okay,
would
then it
suggest you
was
one thing. Today, in fact, tomorrow morning, whenever you want, you can just make all the 6 inverse trigonometric graphs along with its domain and range. If you make it on
Yeah, in
your
a
own,
table.
yeah, make it a table and stick it to your study table.
Yes,
Or
sir.
put it in front of your study table. Okay.
Yes.
So in this interval 0 to pi, tell me an angle for which cos will give you minus of 1 by √2.
3π/4.
Absolutely, 3π/4. So now you can answer this question. What is tan 3π/4?
-1.
-1. Absolutely correct. Okay. Next question.
So the question I asked you.
Yeah, what was the question?
So how will you express cot inverse x in terms of cos inverse x and sin inverse x?
Okay, let's say cot inverse x you want to express in terms of sin inverse x and cos inverse x, correct?
Right.
In terms of sin inverse, I would say, I would not write x, and in terms of cos inverse something, correct? You want to know these somethings, correct?
Right.
See, at the end of the day, cot inverse x is an angle, correct?
Right.
So can I say x is cot of theta? Correct?
Okay.
If you make a reference triangle like this, where you call this as theta, then can I say base by perpendicular is x by 1?
Right.
Correct? That means your hypotenuse will be 1 plus x square under root.
Right.
Correct? Now if I ask you what is sine of theta, what will you say?
It's 1/1 √1 plus x square.
Absolutely. Which means theta is nothing but sine inverse 1 by under root 1 plus x square.
Right.
And what was your theta actually here? Look here. What was your theta? Cot inverse x.
Right.
So cot inverse x in terms of sine inverse will be sine inverse 1 by under root 1 plus x square. Got it?
Okay.
Can you tell me yourself now, once you know, now you've known the process, tell me what will be the expression for cot inverse in terms of cos inverse?
X upon root of 1 plus x square.
Absolutely. So cos inverse x upon root of 1 plus x square. Got your answer?
Yes, sir.
Now, since you have asked this question, let me ask you this question. Write cosec inverse x in terms of cot inverse. So what should be this?
Oh, cosec inverse. So is it root of 1 plus x square by x by 1 plus x square?
Let's check. Again, make a reference triangle. First of all, call this as some angle theta. So cosec of theta is x. So if this is your theta, so this has to be hypotenuse by perpendicular, correct?
Right.
So this will be under root of x square minus 1. Correct? So if somebody asks you cot of theta, you would say base by perpendicular. This is your base by perpendicular is 1, correct? So your theta is nothing but cot inverse of, correct? So that is nothing but your cosec inverse of x.
I took the same triangle I did. I think that's the...
Yeah, the triangle will change now.
Right.
Okay.
Okay, sir. Yes.
So now next we are going to talk about parametrically defined functions. We're going to talk about parametrically. I'm skipping exponential and log part because I'm sure you have done log and exponents in quite detail. Now remember, when we are doing conic sections in class 11th, I also gave you parametric equations for parabola, ellipse, hyperbola as well, right? So
sir, only parabola. You didn't give for ellipse and hyperbola.
So I would suggest we have a lot of videos. I have recorded 8 sessions on conic section, as I told you in the class as well.
Yes, sir.
Yeah, please feel free to look at them in your spare time.
Okay.
So as I already discussed with you in parabola, instead of writing y square is equal to 4ax, we normally can write the same equation as x equal to 80 square and y is equal to 280. Correct?
Right.
That means you're trying to express x in terms of a function of t and y also in terms of a function of t, where t is a parameter. And if you eliminate that parameter, you will end up getting the Cartesian relation between x and y.
Okay.
For example, if I say there is a curve whose parametric equation is this, right? Then what is the curve itself, or what is the Cartesian equation of this curve itself? So all I need to do here is I need to eliminate my t. Okay. So can you suggest me a method to eliminate t from these two equations, 1 and 2?
You eliminate the u. Don't you add them? Don't you square and add?
Square and add. Okay, so very good. So if I square this, I'll get 4 cos square t. And if I square this, I'll get 4 sin square t. And if you square and add them, you will get this. And thereby your t will be eliminated because this is the Pythagorean identity. So you'll get something which is nothing but a
equation
of a circle, right? Are you getting this point?
Yes, sir.
So they may ask you the Cartesian equation of any curve whose parametric equation is mentioned to you. So all you need to do is you eliminate the parameter involved.
Okay.
Is the idea clear how it works?
Yes, sir.
Okay. So let me give you a quick question on this. Let's say you have a curve whose parametric equation is x is equal to e to the power x plus e to the power minus, sorry, e to the power t, not x, e to the power t, e to the power minus t by 2, and y is equal to e to the power t minus e to the power minus t by 2. Okay?
Yes, sir. So idea is to remove the t.
Idea is to eliminate the t, where t is a parameter. So can you tell me the Cartesian equation?
So just one question: if you
Yeah.
take log, will it make an impact, a huge
No,
impact?
because there's a plus sign in between, right? So that it will not be helpful to you.
Okay.
Any idea?
Sir, I added them, but I still don't get anything out of that. I just got e raised to t from that.
Just adding
If
them
I
will not help you, right?
right. Mm. So can you give a small hint? Small.
If you get e to the power t, you can put it in any one of the equation, right?
I got e to the power t.
Okay, so e to the power t is known. That means this is known. So e to the power minus t means reciprocal of that. Correct?
Right.
So in this equation itself, you put it. See what you get.
Plus plus. So can you do the sum? I got some complex thing. I really got some very complex.
Okay. See, you would have done this, right? You would have added these two.
Yeah, then I get x plus y equal to e raised to t.
Correct? So
Right.
1 by x plus y is equal to e raised to the power minus t.
Right.
So
Then you get
these
x
two you
equal
replace
to
it over here. Okay?
yes, sir. I did that.
Yeah. So what do
Then
you
you
get?
get x equal to x plus y the whole square plus 1 upon 2 into x plus y.
Okay. Can I say I get this?
Right.
So which is nothing but x plus y the whole square plus 1 by x plus
y
y.
plus 1.
Okay. I can further simplify it. So this will become 2x square, 2xy.
Equal to x square plus
So one of them
2x
will get
square.
cancelled, 2xy will get cancelled. So you get x square minus y square is equal to 1, which is actually a case of a rectangular hyperbola, right?
Oh. Yeah.
Okay. A simple thing would have been you just do x square.
So x square minus y square equal to 1 is what's a rectangular hyperbola? What's that?
You forgot your hyperbola chapter. X square minus y square is equal to a square.
Oh, right. Sorry.
Okay, so this is a rectangular hyperbola. Okay, so if you do x square, what do you get? E to the power 2t, e to the power minus 2t plus 2 by 4. Correct?
Right.
If you do y square over here, you get e to the power 2t plus e to the power minus 2t minus 2 by 4. Correct?
Correct.
If you subtract these two, what do you get?
X square
You
minus
get
y
half
square.
minus of minus half, because this part and this part from here would be cancelled off.
Correct. Right.
So 2 by 4, which is half, and minus 2 by 4, minus of that is minus of minus half will remain, which actually directly ends up giving you this equation.
1.
Okay.
Okay.
Let's take one more question. A curve is parametrically defined as t square plus 3 and y is equal to t square plus 4. Okay. Then this represents, does it represent a line, circle, parabola, ellipse, or hyperbola? What does it represent?
So a line.
Line. And what will be the equation of that line be?
X minus y equal to minus 1.
Absolutely correct. So you can say y minus x equal to 1 will be the Cartesian form, and that is actually clearly a line. Okay. Next question. Let's say there is a parametric equation which is like this. Okay. So this equation belongs to which of the curves? X square plus y square is equal to 4. X square plus y square is equal to 1. 4x square plus y square is equal to 4. 4x plus y square is equal to 4. Or option E, x plus 4y square equal to 1.
Sir, I think the answer is D.
D.
Yeah.
Absolutely correct. Okay. So 4x will be like this. Y square will be like this. And if you add it, you'll definitely get a 4. So this is going to satisfy. So D is the right answer.
Okay.
Okay.
Yes.
Now coming to sketching of the graph. Sometimes you will be asked to sketch the graphs. For example, let's say I would like you to sketch this graph. Have you learned how to work on your calculator?
No, sir, not yet. I will soon. I will.
Okay. So let's say they may ask you to sketch the graph of the path of a satellite which follows this parametric equation. from t lying between 0 to 2 pi. Okay. Now I'll show you on GeoGebra how to do it, because even calculator I cannot show you right now. So let me just okay. So in case of GeoGebra, normally we have some special functions. It is called curve. Okay. In curve, we actually write down. This is the format of curve. It takes in two expressions. First is for x, second is for y. So just let me write down over here. So it is 4 cos t
plus cos 12t.
Cos of t. Okay. And this will be 4 sin t plus sine of t. Oh, what happened? So 4 cos t plus cos of 12t. This is 4 sin t plus sine of 12t. Here parameter is t. Start value is 0. End value is 2 pi. Okay, so the path of the satellite will be like this.
Oh my god. Okay.
Okay, so I think this, your graphing calculator should be able to plot this graph. Okay.
Okay.
So they may also ask you what is the value of x and y at a particular value of t as well.
Okay.
For example, let's say they'll ask you what is the value when t value is pi by 2. What is the value of x and what is value of y when t is pi by 2? So
pi by 2.
T is pi by 2 means 90 degrees. So it will be this value that you are looking at, this value. This value A.
Oh.
Okay, so T is basically a parameter which is covering angles like this, 0 to 2 pi.
Oh, right.
So for example, here T will be 0. At C, T will be 0. At A, T will be pi by 2.
Okay. Okay.
Like that. So at T equal to pi by 2, your X will be approximately
0.
5, I think. Sorry, X will be 0. Because this will become 4 cos pi by 2 plus cos of 6 pi.
Oh, right. Yes,
sir. No, but 6 pi.
Pi by 2.
6 pi should be 1, right?
No. Right, yeah. 1.
0, it will be 5. At pi by 2. It will give you 6 pi. 6 pi should be 1. This will be, y will be 0 at this point. So this is not pi by 2 point then. This is something else.
Sir?
Hello?
Yes, sir. I can hear you.
Yeah. Now this point A doesn't correspond to t equal to pi by 2, I believe.
Okay.
Because at t equal to pi by 2, it should have given you x value as 0, right?
Correct.
So this point is not giving you 0. Sorry,
Okay, then.
when you put pi by 2, this value of x is not 0 at that point.
Right.
Correct. This is actually giving you 1.
Correct. Right.
Correct?
Yes, sir.
And it actually should be this value. X value is 1 and y value is 0. X value is 1 and y value is 0. X value is 1 and y value is 0. So x will be 1 and y is 0. Where is that happening?
Hmm.
Right now it's not happening in this graph. But this C point is correct, right? We are getting C point when we put t as 0, right?
Correct.
So when you put t as 0, x becomes 5 and y becomes 0. So this corresponds to t equal to 0 point.
Correct. Yeah.
Okay.
Right.
Okay, so this is actually taking a turn over here. Okay, and going again. So it's periodic within that. See, the idea is every point on this graph has one t value for it. C has a t value, A will have a t value. So I'm trying to guess what is the t value for A.
Okay.
So can you take a call? What should be t value for A? Because A is a point where x is x is 0 and y is 5. It cannot be pi by 2 for sure. Because if it is a pi by 2, then x value would have been 5. Sorry, x value would have been 1.
Yes, x value. Yeah.
And y value would have been 4. It is actually this point pi by 2. This point is the point for pi by 2. See, I'll mark it on the graph. This is the point. J is the point for pi by 2.
Cos pi is -1, right?
Cos pi is -1, correct.
Okay.
So J is the one which corresponds to pi by 2. As you can see, x value is 1 and y value is 4. Okay, so from this graph you cannot make a direct conclusion that okay, this is 90 degree or this is 0. This 0 is fitting fine, but pi by 2 is coming at J. Okay, anyways, the AP is not going to ask you till that extent.
Okay.
Okay, fine. So now we are going to talk about this we have already plotted. So now we are going to talk about something called polar functions.
So this is the last topic, right?
Yeah, last topic in functions. Now, polar function basically is a way. First of all, polar coordinates we'll understand. I think we had already done a bit in complex number chapter.
Complex numbers.
Polar coordinates was actually invented by Newton, where instead of representing a point by x and y coordinate, he started representing a position of a point by mentioning its distance from the origin, which he called as r, right? And origin was actually called the pole. This is actually your pole. Hence the name polar came for this coordinate. and this angle, and stating this angle theta. So for example, if you wanted to represent a point 1 comma 1, you would actually write it as root 2 comma pi by 4. Okay, so if you want to state a curve by representing its polar equation, right, then that
Yes,
would
sir.
be giving you a function of r in terms of theta. I'll give you an example. Let's say I want to represent a circle, okay, whose radius is, let's say, 2 units.
Okay.
Okay. Now, if I want to write the polar equation for this circle whose radius is 2 units, I would simply write r is equal to 2.
Right.
Why? Because if I take any point, its distance from the origin will always be 2. Correct?
Right.
This will always be 2. This will always be 2. So for such a circle, this will become its polar equation.
Okay.
A direct correlation between x, y, and r is nothing but r square is equal to x square plus y square. Okay.
Yes, sir.
Direct relation between theta and x and y is tan of theta is y by x.
Okay.
From where do we get this? Very simple. If this is r, yeah, if you make a Pythagorean reference triangle, this is your x, this is your y. So by Pythagoras theorem, it will be r square is equal to x square plus y square. And if you apply a trigonometric ratio over here, y by x is tan of theta.
Right.
Okay.
Yes, sir.
So you may also be asked a question where you have to convert a polar form to Cartesian form.
Okay.
Okay. So for this polar form, the Cartesian form equation will be x square plus y square is equal to 4.
Okay.
Okay.
Yes.
Now, mostly whenever you will be asked questions to sketch a graph which will be in terms of polar, you would be asked to use a calculator.
All right.
Okay. So for example, I will tell you certain well-known graphs that you should be knowing. For example, r is equal to theta graph. This graph is actually a spiral.
Oh.
Let me show you on GeoGebra. But please do learn on your this thing as well. R is equal.
Yes, sir. By the end of the week, I'll learn it.
You see this? It's a spiral.
Okay.
Okay. Let's say r is equal to 4 sine 2 theta. This graph is called a rose.
Oh.
Okay.
Okay.
I will show you a few more. For example, there is a graph called cardioid. R is equal to twice 1 plus sine theta. This graph is called a cardioid because it resembles heart upside down.
So what is it called? What is the name?
Cardioid. I'll write it down.
Oh, spell it.
I'll write it down. It is called a cardioid.
Okay.
Okay.
Yes, sir.
I'll show you a few more. R is equal to 1 plus, let's say, 3 cos theta. This is called a limacon.
Okay.
Again, it's not important to know their names, but just for your information, this is called a limacon. Okay.
Yes, sir.
Remember, the polar questions can be done only through the use of calculator.
Okay.
So let me try to take a question on this. What question can come on this? Let's say consider the polar function. In undergrads, you'll be using polar function very heavily.
Okay.
So let's say this is a polar function. Okay.
Mm-hmm.
First question is, for what value of theta? For what values of theta belonging to the interval 0 to 2 pi does the curve pass through origin? What is the meaning that the curve is passing through origin? R should be?
R should be same at
If a curve is passing through the origin, polar curve is passing through origin, that means distance from the pole R should be?
constant.
Hey, 0.
So
Zero.
what? No.
Shreya, when will R be 0? When will the curve set to be, let's say I make a curve like this. Let's say I talked about cardioid, right?
Right.
What is happening at this point? The curve is passing through origin, right?
Right.
So at this point, what is R?
Oh, R is 0.
R is 0. Correct. So in the same way, the question is asking you.
Sir, isn't this a cardioid? Isn't this supposed to be just a right?
It's actually a limicon.
No, because it's just
Let me
two
draw it.
times of
Let me
one.
draw it for you. R is equal to 2 plus 4 sine theta, right?
Right.
Like this.
Oh, okay.
So they're asking you what should be theta at this position.
Oh.
Okay.
Oh,
So
okay.
all you need to do is use your trigonometric equations. That means you just equate this to 0. Solve for theta.
Oh,
That
okay.
means sine theta is minus of half. So tell me, in this interval 0 to 2 pi, when do you think sine theta becomes minus half?
Minus pi by
Again, is minus pi by 6 in this interval?
0 to 2 pi.
Yeah, in 0 to 2 pi, when is sine theta minus half?
Oh, again 0 to pi minus pi by 6. 5 pi by 6.
Is it time for you to sleep? Something?
No, sir. Why?
Sine pi by 6 is minus half. Since when?
What?
Sine 5 pi by 6, is it minus half?
Oh. Mm. Oh, wait. Sine? No. Sine 5 pi by 3. Oh. Isn't sine 30 just pi by 6? So isn't it? Oh, pi. What? Sine theta is what? Oh, it's pi 2 pi minus pi by 6. So 11 pi by 6.
Is that the only value? That's correct. But is that the only value?
Or you could have pi plus.
Okay. What should the answer then?
Pi plus minus pi by 6. So which is pi minus pi.
Shreya, relax. Sine is negative only in the
third and fourth.
So how it can be pi minus pi by 6? It will take you to the second quadrant, right?
Sir, but if it's in the second quadrant, it should be pi of minus, correct? I'm not saying that. I'm saying pi plus minus pi by 6.
Pi plus minus pi by 6.
Right.
So doesn't
No,
it
sir,
mean,
no, not that.
Doesn't it
Not
mean
that.
two things?
Not that, sir.
Then?
Pi plus minus pi by 6 is the angle.
Oh, you're saying pi plus minus pi by 6.
Right, which is pi minus pi by 6.
Which is wrong.
So how the angle is minus pi by 6?
Common sense लगाओ ना. You will go in the second quadrant with this. Second quadrant में positive हो जाता है sign. Sign becomes positive.
Or you could do 7 pi by 6.
What or you could do? This is the only thing that you can do.
Yeah, okay. 7. So, I mean 11 pi by 6 or 7 pi by 6.
Right. So these two are your answers. So much time will you take? So simple thing. Negative is you have to just do pi plus pi by 6 or 2 pi minus pi by 6. Simple.
Yes, sir.
You are writing an exam which the world is writing, not in India is writing. World is writing that exam.
Yes, sir.
Next is for what value of theta? For what value of theta belonging to the interval 0 to pi by 2 does the curve intersect? Does the curve intersect r equal to 3 circle? So basically, if you look at the diagram, r equal to 3 will be a circle like this. What is this? One second. Yeah. R equal to 3. I don't know why it is taking it as this thing. R equal to 3 will be a circle x square plus y square
Equal to 9.
Yeah. So they're asking you for what values of theta between 0 to pi are these two intersecting. That means they want theta corresponding to this point, A. What will you do then?
You will equate it to that point was. I can't read that. It's too small.
Correct.
Okay.
Equate it to 3. So sine theta becomes 1 by 4. So theta is sine inverse 1 by 4. So calculate this on your calculator. your answer will approximately come out in terms of radians. I'm saying 0.253.
Okay. Okay.
Okay.
Yes, sir.
Let's take one more question. This one is a simple one. Find xy coordinates on the curve whose parametric equation is r equal to 1 plus cos theta, where theta is pi by 3. Where theta is pi by 3. How is x and y related to r? First, understand this.
R square equal to x square plus y square.
That's fine. But if you actually see through the coordinates, this is r and this is theta. So if this point is, let's say, x comma y, then this point is actually your x, which is nothing but r into cos of theta. Correct?
Yeah.
This is nothing but y, which is nothing but r into sine of theta. Correct?
Right.
Okay. Now they're asking you x and y coordinate for such a point where theta is pi by 3. So if theta is pi by 3, what will be r at that point?
So I think is x 3 by 4 and 3 root 3 by 4. X and comma y.
Absolutely correct. So basically, what is r then?
R is 3 by 2.
Okay. So if you put over here, it will be x equal to 3 by 2 cos of pi by 3, which is 3 by 4. And y will be 3 by 2 sine of pi by 3, which is 3 root 3 by 4.
Right. Yes.
Okay. So this point here will be 3 by 4 comma 3 root 3 by 4. In general, if your function is this, then x will be nothing but f of theta cos theta, and y will be nothing but f of theta sine theta. Okay. Why I'm telling you this is because sometimes they would always also ask you what is dy by dx for that function at a given theta. So how do you find dy by dx? I today only I started doing differentiation with you. So in that I will tell you something about the parametric differentiation, but you can note it down now itself. So let's say if you want to find dy by dx for a curve which is expressed in terms of polar form, so you can say dy by dx is nothing but dy by d theta divided by dx by d theta. Correct?
Yes, sir.
Now what is dy by d theta? So what is the derivative of this with respect to theta? What will you say? You'll say f of theta into cos theta
Cos theta.
plus f dash theta into sine theta.
Right.
Okay, which rule have I used over here? Product rule.
Quotient. Yeah, product rule.
What is dx
And
by
then
d
you
theta?
use quotient rule.
There is no quotient rule.
Sorry, not quotient rule. Sorry.
Yeah. What is dx by d theta?
F minus f sine theta plus f dash theta cos theta.
Is that fine?
Yes, sir.
Okay, so let's say I give you a question in this curve itself. Find the derivative at pi by 3. This question itself. R is equal to 1 plus cos theta. Find the derivative of this at pi by 3.
was one question. Won't f dash theta always be a? Isn't it a constant?
Sorry?
Isn't f f theta a constant?
How
So
is f
won't
theta a
f
constant?
dash?
How is f theta a constant?
R is.
This is f theta. How is it a constant? Theta is changing, then f theta will also change.
Okay.
See, f of theta is 1 plus cos theta given to you.
Sir, I'm almost done. Just 2 seconds. So what's the answer supposed to be?
What are you getting?
0.
Okay, let's check. F of theta means 1 plus cos theta
Into cos
theta. F dash theta means minus of sin theta into sin
theta.
Divided by minus 1 plus cos theta
into sin theta plus minus sin theta cos theta.
Okay.
Right.
Now put the value of theta as pi by 3. So this becomes 3 by 2. This becomes half. This becomes minus root 3 by 2 into root 3 by 2.
So that becomes 0, right? Numerator.
That becomes 0, absolutely. So this becomes 0. So I don't need to care about denominator. Its answer will be 0. Is that fine?
Yes, sir.
Let's take this one. Find theta belonging to the interval 0 to pi where these two curves r equal to 3 and r is equal to 2 plus 2 cos theta intersect.
So doesn't that mean that 3 is equal to 2 plus 2 cos theta? No.
Correct. Yes. When they intersect, their r should be the same, right?
Yeah, right.
So 3 is equal to 2 plus 2 cos theta. Tell me a cos theta. Tell me theta between 0 to pi.
Okay. Pi by 3.
Pi by 3. Absolutely correct. Okay. Theta is pi by 3. Next question. If r is equal to 2 cos 5 theta, right? What is the smallest theta? What is the smallest theta belonging to the interval 0 to 2 pi for which this curve passes through origin? Passes through origin.
So that means you equate it to 0.
Right.
Theta is pi by 10.
Absolutely correct. So you just have to do this as 0. That means cos 5 theta is 0. That means 5 theta should be 90 degree. So theta is pi by 10. Okay.
Yes, sir.
One more will take up.
So you're not starting limits and continuity today?
No. We'll start it next week. Probably next week I'll take some longer classes for you.
All right.
Okay. On the interval 0 to 2 pi, there is one point on the curve r is equal to theta minus 2 cos theta, whose x coordinate is 2. Okay. Then y coordinate at that point is, option A is minus 5.494, option B is minus 3.764, option C is 1.979, option D is 4.263, and option E is 5.201.
So don't we use the relation r square equal to x square plus y square?
Use it.
Okay.
Does it help you?
I don't think so.
Here you cannot solve it by without use of calculator.
Oh, as in the graphing calculator?
Yeah.
So I'll learn before the next class, sir.
Yeah, it's
Sure,
important because without calculator we cannot do most of the questions. See, what is given to us is x coordinate. X coordinate we all know is r cos theta, correct?
Yes, sir.
So this is given to us as 2. That means theta minus 2 cos theta times cos theta is equal to 2. Okay.
Yes.
Now how do I get a theta for this? For that I have to make a graph. Okay. Something like this. X minus 2 cos x into cos x. Okay. And see where it intersects y equal to 2 line.
Oh.
Okay. So I have to see the intersecting value for this.
Okay.
So right now I'm showing this on GeoGebra to you.
Okay.
Yeah. So y is equal to x minus 2 cos x times cos x. This is the graph for that. Okay. And y equal to 2 line is this. So the first value that I see them intersecting is here. As you can see,
Right.
x here is 5.2. You see here?
Yeah.
Okay. So my y value would be 5.2 radians. Okay. Don't take it as degrees.
Okay.
So my y value will be r sine theta. Okay. Where theta I will use as 5.2 radians. Correct. So it will be
Okay.
r means theta minus 2 cos theta into sine of theta. So that means it will be 5.2 minus 2 cos 5.2 radians, whole thing into sine 5.2 radians. Right? Use your normal calculator, put it in radians mode. Okay, and evaluate this. This value would come out approximately to be minus 3.764. That's option B.
Okay.
Okay, but next class, make sure that you learn your how to operate your calculators, especially with sketching the
Yes, sir.
graph.
Yes, sir.
So fine, Shreya, we'll call it a day now.
Okay, fine.
See you next week, Saturday.
Yes, so you're going to increase the time? To
Probably
4
by
hours?
half an hour or so,
Yeah.
I'll increase it so that we can make up for the lost time.
Okay, so and there'll be a test after this?
Yes, after completing continuity, as per the POW, we'll have a test.
All right.
Okay.
Okay, sir.
So I'll send you more questions today.
Yes, sir. Okay.
Okay, thank you. Over and out.
Okay. Thank you, sir. Bye-bye.
Bye.